Doing well. This is a follow-up to an in-class lesson and demo that we've been doing for the past 2 days, purely for experimental purposes. After studying CPUs, the manufacturing process, and understanding how central processing units work, we took out the CPU cooler and ran some stress tests such as PyCruncher and so forth, and then used a fluke thermal imaging camera to take some thermal images, as well as maintain a system monitor to kind of keep an eye on CPU usage to see if we could see evidence of thermal throttling. The CPU eventually did shut down at around 196 degrees Fahrenheit. The system became inoperable, and then upon restart and cool down, the PC was able to run. The CPU was not damaged, at least permanently damaged. I'm sure we took some life expectancy off of the total estimated life of the CPU. However, the PC was still able to boot up. So what I did one step further is you can see the heat spreader is sitting on top of the processor. This normally is thermally glued to the processor, and you can see the processor here. So I removed this. Instead of thermal paste, we have thermal adhesive. And so at the manufacturing level, this is obviously permanently glued onto the silicon chip here. So I was thinking that the heat spreader itself was dissipating enough heat to keep the processor from permanently being damaged. I would like to do this live with my classes, with all of you, and I don't know if I'll only get a one-chance try. So I like to do everything obviously in the lab prior to doing this in front of class. So in case this is a one-time deal, I'm recording this video. So this screens that you see here is the downward facing view of the hardware, and over here is obviously the monitor, which is hooked up to the PC itself. So I'm going to boot this up. It's a standard Windows 10 build, and we're just going to see if we can get into Windows moving forward. So let's take a look. I'm going to power it on right now. We'll see if it does a post. No, it's shut directly off. That being said, I'm going to quickly thermal image the CPU on boot up. So I'll just kind of give you a visual of kind of what you would see, because I don't have a way to put this. As you can kind of see the thermal image of myself here. Right? So I clearly don't have COVID. So taking a look back at the CPU, I'm going to just boot this up really quick again. See if it does a post. CPU was very, very hot. As you can see here, instantly got over 200 degrees Fahrenheit without having the metallic heat spreader. This is a solid piece of metal, and like I said, it was thermally adhered to the actual chip. I try one more time, just to once again get another image. So I'm going to do a before and after. The heat map that I'm going to show you is a relative heat map, meaning the darkest temperatures is the hottest that you see in the frame. Okay, so we're around 86F in the center. As soon as I turn this on, the power on self-test checks the processor, and it instantly gets hot. Far quicker than the previous time that we did this in the lab. So right now we're at 85. Power on self-test, 140, 150, 160, 170, 200, 225, it's off. So 225 is the highest temperature, and that does sound familiar in terms of when we were able to get the PC to shut off around 260. So 260 seems to be the magic number. And this repeats my findings, and it doesn't seem like it permanently damaged the processor. I'm going to try to just press this down onto the actual processor to see if I can get it to possibly get through to the power on self-test, to possibly boot up Windows before it gets too hot. So we're not going to obviously nearly take as much heat away by doing this, but once again, what we're trying to do is just take a little bit of the heat away so that it doesn't shut down so quickly. And by doing that, See if I can get the heat sink on. I think I'm gonna have to take the this off. Let's see if we can get this on. I have to match the existing shape. That's the hard part. Okay, it was on this way. I can see the shape, the pattern of the glue, and the pattern of the glue here. So this was on the processor, and it should fit in the way that it was prior to being glued. Now I've removed it, so it's obviously not going to dissipate the heat the way it should. And these little tabs here are actually pressing this down, so we actually have some pressure. But once again, you would never do something like this to your own personal computer. This is once again a deconstructive test to see, like, you know, what we can learn from this and understand how processors work a little bit differently than just textbook. So let's turn it on and see what happens. Post is happening. Alert, previous attempts at booting the system have failed. We know why. And there's no CPU fan, of course, so we're going to press F1 to continue. Let's see. So what's happening currently right now is the metal itself is cold. So it's going to take a while for that heat to conduct through the silicon chip up into that metal plate. So what you can see, I don't understand why my camera's not showing up. That's bizarre. I'm not sure why my video display over there in the monitor is not showing what it should show. That's a little bit weird. But anyway, with that being said, Windows 10 is working. If I were to point my webcam, sorry for the lack of production value here, but you can clearly see it's booting up, right? It's there, it runs. So there's no way I can remove that heat spreader while the PC is running. So we were able to get it to dissipate the heat through just the contact of the actual heat spreader. I'm going to shut down the PC. There's a couple other things that I'd like to do, but once again, the reason why I'm recording this is purely so that I can, if this was a one-time experience, I'd have it recorded. So at this point, I'm going to stop recording, and there might be a follow-up video to this if I find anything more interesting. But we did learn the fact that that metallic heat spreader that comes with the processor by the manufacturer, thermally adhered, that thermal adhesive is obviously critical. And obviously from that perspective, moving forward, your CPU cooler is obviously pulling the heat away from that. But without this, it instantly gets above temperature and then dies. So have a nice day.